Welcome to our first video in the trigonometry unit. In this lesson, we're going to review SOHCAHTOA and the Pythagorean theorem. So both SOHCAHTOA and the Pythagorean theorem have to do with right triangles. So this is a diagram of a right triangle. And we usually denote the right triangle or the right angle as a little square in the corner, which means 90 degrees. And in this right triangle, we have the hypotenuse, which is the longest side, and then two legs. If we're looking for the ratios for solving for an angle or a missing side, we use the acronym SOHCAHTOA to help us remember it. The S stands for sine. It's always going to be sine of some angle. I'm going to call that theta as our angle. The O stands for opposite. The H stands for hypotenuse. So that means if I want to find an angle, or if I want to find a missing side, and I have the opposite side of that angle and the hypotenuse, I'm going to use sine theta. Now, where's the opposite? It really depends on what your reference angle is. Let's just say your angle is over here, and that's theta. Then directly across from that angle is called the opposite side. So let's just say I was given the opposite side and the hypotenuse side, and I knew the numbers for that. That means I can find the angle theta. Or if I was given the angle theta and I had the opposite side, then I can find the hypotenuse, and that's how it's related. But that angle doesn't need to be specifically that one. It could also be this angle here. If that's the case, then your opposite side is directly across from that angle, which is actually down here now, but of course your hypotenuse does not change. So that's what it could look like for sine theta. The other ratio is cosine theta, which is adjacent over hypotenuse. So your adjacent side is the side that's right next to the angle. So that's where it would occur on the first diagram. On the second diagram, it would be this one here, the adjacent side. Then lastly, we have tan theta, tangent theta, which is opposite over adjacent, which means that we're going to use our opposite and adjacent, and we don't care about the hypotenuse at all. So those are three ratios. We also know how to find angles by using the inverse function. So if I want to solve for an angle, I can use sine inverse of opposite over hypotenuse. I can also use cos inverse of adjacent over hypotenuse. And I can use tan inverse of opposite over adjacent. And to get your inverse functions on your calculator, you're going to have to press second function sine, second function cos, or second function tan. Let's do some examples using SOHCAHTOA. So in example 1, I'm looking for x, this missing side. I've been given this angle over here, which is 25 degrees, and the hypotenuse is 13. So I need to recognize what sides I actually have. I have an opposite side that I'm looking for, and that's directly across from our angle of 25 degrees, and we also have the hypotenuse. Now, out of sine, cos, and tan, the only ratio that has opposite and hypotenuse in it is sine theta. So we have to use sine theta. Now I'm going to fill in the information I know. So I know the angle is 25 degrees, and I also know the opposite is called x, because we're looking for it, and our hypotenuse is 13. So that was our very first step, to determine which ratio we are going to use and then fill in the information that we do have. Our next step is to solve for x. In other words, I want to isolate x. by itself. Right now I have this divide by 13, and to get rid of that I just need to do the opposite operation of divide, which is multiply. So here I'm going to multiply both sides by 13. Again, I'm going to multiply because that's the opposite operation of divide, and I want to get x by itself. So that means I have 13 times sine 25 degrees is equal to x over 13 times 13. 13 divided by 13 is just 1, so that's just gone. And this is what I need to put into the calculator. So our final step is just putting this into the calculator. In your calculator, you want to find what sine 25 is, press equals, then divided by, or then multiply by 13. So sine 25 is going to give you decimal number, which is going to be about 0.422618 and so on. Then press multiply by 13. You should get 5.49. So remember that this is a length, it's a missing side. The units were not given to us in the original question, so I'm just going to leave our final answer without any units. Moving on to the next example. So for example 2, I actually want to find an angle in this case, but I've been given the sides. So directly across from our angle that we're looking for, this is called the opposite side, and a side right next to that angle is called the adjacent. And remember, the longest side is called the hypotenuse. We're not given any information about the hypotenuse, so I'm not even bother to write down hypotenuse on our right triangle. So we're concerning ourselves with adjacent and hypotenuse. Out of the 3 ratios, the only ratio that has adjacent and hypotenuse in it is tan. Now, if we go back to our information here, we have these two for tan, and I'm looking for an angle. So if I want to look for an angle, I should use a tan inverse one, tan inverse of opposite over adjacent, because I am looking for that angle. And then I'm going to fill in my information. So opposite is 4, adjacent is 7, and then we're going to find tan inverse of 4 over 7 and put that into our calculator. Remember, to get tan inverse, you have to press second function tan. You should get 29.7 degrees. And that would be your final answer. That's it. So whenever I'm plugging something into a calculator, make sure that you're also doing it yourself to make sure that you are getting the same answer as me. Because if you're not, then you have to reevaluate to see how you're plugging it into the calculator wrong. The last topic we're going to cover is the Pythagorean theorem, which is a squared plus b squared is equal to c squared. That is your theorem, where a and b are legs of the triangle, remember it has to be a right triangle, and C is the hypotenuse. So that means that 13 is C because that's the hypotenuse, and it doesn't matter what I assign for A and B. Let's just say A is 6 and B is what we're looking for. Of course, you can reverse it. B could be 6 and A could be what you're looking for. It really doesn't matter as long as you're consistent. So I'm going to fill in our information for this a squared plus b squared equals c squared. And just as a side note, in case you forgot, the Pythagorean theorem is for finding sides and only sides. It can't help you find any angles, so only sides of a right triangle. Now I'm going to fill in my information. So A is 6, B I don't know, so I'm going to leave it alone, and C is 13. I'm trying to get B by itself. But before I even do that, I can see what 6 squared is and 13 squared. So 6 squared is 36. Remember that 6 squared, anything squared, is multiplying by itself. So that's 6 times 6 is 36. And 13 times 13, which is 169. Now to get B by itself, I'm going to subtract 36 on both sides. So that I can get rid of that 36 on our left-hand side of the equal sign. So 169 minus 36 is 133. Our last step is to square root both sides. So we're going to get B, after I square root B squared, square root of 133, and that's 11.5, and we don't have any units, so I'm just going to leave that as is. And that would be our final answer.